So my name is Willem Tulp. I'm a data visualization designer, and I create data visualizations just like this. And I do that by writing code. I work from the start to the end on data visualization project. I have my one-person company. And today I'm going to tell you something about how to communicate insights in data. I also must admit upfront that I have never done a project specifically for one of the Sustainable Development Goals. So, but at the same time, there are so many organizations that work with data today, and I've also worked for large NGOs, so it was actually quite easy for me to attach some of the Sustainable Development Goals to some of my projects. So today I'm going to show a mixture of, well, non-sustainable development goals and sustainable development goal related project. And specifically today, I would like to talk about reality and aesthetics a little bit. Reality and aesthetics are very philosophical topics. Philosophers have written and discussed about this for centuries. But I'm not a philosopher myself, so unfortunately, this man was. And this is Ernst von Glaserfeld. I'm currently working at a project with the University of Innsbruck in Austria. And while working on this project, we're trying to visualize philosophical text that he has written. And while working on this project, I came across, well, obviously some of his quotes. And there was one in particular that stood out for me, and I want to show you that.
Really, it should have been obvious.
Yes.
For a long time, and I think it has been obvious to whoever was or were the good teachers in the past. They realized full well that you cannot transfer knowledge from a teacher to a student as though it were a commodity that you can just transport from one head into another. They realized that in some sense the student always has to build his own knowledge or her own knowledge. And that is a very different process from the one that was assumed to be a reception of something that is ready-made into the head.
Yeah, so I think it's very important to what he says, and also applies to data visualization. Knowledge is not a commodity you can transfer from one mind to another. Users have to construct knowledge in their own mind. And so, since with data visualization we're always communicating insights and knowledge, I think for data visualization this should also be something of value, that data visualization should actually facilitate the fact that users should be able to construct knowledge in their own mind. This is my own little model of data visualization. So we have the world around us. We collect data of the world around us, which is the what. Then we turn that into some kind of representation. Most of the time it's visual. We then perceive or interact with this representation. And then we can ask questions about this. And that's our indirect way of understanding the world. But each of these three components has their own kind of challenges. So the first one is when I think of data, I think of something like this. You take a picture of the food in front of you with your phone. Now, obviously, the picture itself is not reality. It's just an abstraction of reality, a certain moment in time. The food itself is reality. You can move it around, eat it, leave it there, see what happens. But the picture is not reality. So if this is one data point, you might say that the next slide, yeah, this one, that this is a data set. So you would say that if you look at this, this is a guy doing a backflip. But actually, that's not true. What you're seeing is multiple pictures of a guy doing a backflip. But this is the way that we interpret data. But you have to be aware of the fact that in order for the photographer to take this picture, he or she took a lot of decisions. So who's the model going to be? How many pictures am I going to take? What's the lighting going to be? Am I going to stand still or move around? And this is also true for data visualization. Whenever you work with data, you have to be aware of the fact of how data was collected, are there some biases in data, do you select a subset, etc. So there are always choices and opinions when you start working with data. And here's a great example of someone who collects completely unrelated data sets. that have a very strong correlation. So statistically, they're very strongly correlated, but as you can see, they have nothing to do with each other. So here's a good example of well, for the purpose of this chart, it was a good selection of data set. The representation also has some challenges. So this comes from a website called TreeVisNet, and it's a collection of all kinds of techniques to visualize tree-structured data. And it's all kinds of techniques developed by researchers. It contains over 300 ways to visualize tree-structured data. So you already have to make a choice here. What's your way of showing this tree-structured data? And I'm not even talking about making combinations or your own variations and things like that. So again, at the representation level, there are a lot of choices involved. And here you see Steve Jobs showing the market share of the iPhone. The green area, 19.5%. The purple is 21%, so bigger, but he uses a 3D pie chart, which is generally considered to be bad practice. And I can illustrate that if you overlay an actual circle. You see that there's a lot of empty space on top and more space at the bottom, and also the thickness of the chart adds a bit more to the green. So the amount of green available here is of a value that's lower than the purple one is even bigger. So I don't have data on this, but I think this is deliberate manipulation. For the humans, there are also challenges. You're always dealing with someone, your audience, someone you create this data visualization for. And there are different levels of visualization literacy or data literacy or domain knowledge. And so being aware of some of this knowledge is very valuable. So let me give you an example. This is a hurricane map. And just raise your hand. Who thinks the hurricane gets bigger over time based on this map? Yeah? A few people? Yeah? So basically what you're thinking is, this is what's happening, right? It's not true. This is what's happening. Researchers have calculated multiple paths the hurricane could possibly take. And what you're seeing is the uncertainty. So they also call this the cone of uncertainty. And the further in the future, the more uncertain you are, so therefore it becomes wider. So, and that's the shaded area. These charts were originally created for people who work with climate data or weather data, and so they are the experts, so they understand it. But today, these types of charts are also communicated to the general public. But the fact is that a lot of people don't understand these charts, or at least misread these charts. So having some understanding of who you're creating your visualization for is also very important. And based on the previous chart, which was recently published by the New York Times, I asked on Twitter if people had more suggestion of charts that in principle nothing is wrong with them, but people have a hard time understanding it. So here you have logarithmic scales, nothing wrong with it, but yeah, a lot of people have a hard time understanding the concept. That's a connected scatter plot, so it's a normal scatter plot, but several lines are connected. Also very confusing. Error ranges in general, also confusing, and it suspiciously looks like a bar chart, but it is a histogram, so it's also not very easy for people to understand. So, yeah, this is my quote, and probably many other people, but data visualization is always subjective, opinionated, and it's an interpretation of reality. There are always choices involved. So the other topic is aesthetics. And the goal of aesthetics is, this comes from a research paper on aesthetics in data visualization. And so it is to attract attention, encourage personal involvement, create long-term expression, so to create something engaging. People think it's beautiful, like to spend time with, etc. So if you think about what Ernst von Glaserfeld, the philosopher, said, that users should be able to construct knowledge themselves, then I think aesthetics plays a crucial role there, because the more time people spend with a visualization, or the more they're attracted to it, the bigger the chances are that they actually are constructing this knowledge. So let me give you an example here of two types of visualization. This is one visualization I created earlier this year. It's about European elections, and when there are elections, there are many websites where you have a statement, and then you have to say, I agree, disagree, or neutral, and then you go to the next statement, and at the end, you can set some weight to say, these statements are more important to me, and then finally you get an answer, and it says, well, your opinion matches for 70% with this political party. And it's perfectly fine, and if people find it helpful, absolutely use that, because a well-informed vote is very, very valuable. But whenever you go out to vote, you never vote for 70% on a political party. It's always 100%, even if you disagree to some degree. So that's why I created this visualization. And what you're doing here is you can also say, I agree or disagree or neutral. But first of all, you only have the options the political parties actually gave. So you cannot select an opinion that no political party supports. Then once you make a choice, you're automatically eliminating all the possible, the non-possible paths anymore. So you quickly converge to a solution that is a unique solution specifically for that political party. And some of the things that you can get out of this is that it turns out that some political parties only differ on one statement, or it turns out in the United Kingdom there's one statement and all political parties have the same opinion. So if you have a different opinion and it's very important for you, then you're out of luck, because there's no party that supports it. So this is just an alternative way to get a more informed vote. This is a very informative visualization. This is another visualization I did several years ago. It's for Nielsen, and Nielsen is a marketing intelligence organization. They do a lot of research on the consumer market. And at the time when they approached me, they asked me to create a data visualization as part of a new corporate identity they were developing. Because they wanted to have reports and then use data visualization to beautify the reports. And so this was my assignment: create several visualizations based on real data, but purely for aesthetics. So you shouldn't be able to see what it was about, which is kind of counterintuitive for many visualizations, because you want to get insights, but here you don't want to see what the insights are. There was one constraint for me, which is the colors I could use, and that absolutely makes sense for a corporate identity. I received a data set. At that time, it was the largest Excel file I received. It took me 20 minutes to open it. And there were 7 years of sales data in this Excel sheet. So all kinds of products, hierarchies of products, time series, 60-week time series of the price development, all kinds of attributes like launch date, etc. So a lot of information. So the way that I approached this project was I created first all kinds of different visualizations, then we would select one or two, and then I would create different variations based on the one that we selected. So here are a few examples of the visualization that I created. Well, if you just look at it, it's just, yeah, nice looking image. You don't know what it is about. But since based on actual data, I could explain this. So for instance, every horizontal line is the starting point of a 60-week period, and every column is 60 weeks, so you see small blocks, and that's 1 week. And I determined my own rules. So my rule was it becomes more blue if the gray is the starting price, so it becomes more blue if the starting price is higher than the starting price, and more red if the price becomes lower than the starting price. So basically this is a very big heat map of all kinds of products. So if you would add labels or make it interactive, it would become a valuable visualization, but now it's just kind of a pretty picture. Here's another one, a bigger group of products. Yeah, you can also create a line chart and overlay everything, and here the color is determined by the starting price and the end price. You can also create a network of product hierarchies, and depending on the level of the hierarchy you pick, you can create different images. And yeah, if you can create a straight line chart, why not a radial line chart? That's also possible. And it turns out that they like this one most. So this was the one that we continued working on, and I created multiple variations of that. But you have to realize that I work with a very large data set, and since I write code, it could mean I have to change my code, look at my screen if it's something, and then go back to my code, change it again, and that takes a lot of effort, also considering the huge number of visual variables that you can play around with. So what I did was I created a tool for myself, and with this tool I was able to browse this data set, and using key combinations and mouse movement I was able to influence the visual representation that you see. So you can see the distance between the lines, the markers that I would use, the colors, the way the lines would start, etc. And this way I spent the full day just browsing this data set and saving nice pictures and browse and save. And here are some images that eventually went to the client. And since it's based on actual data, you see that some of the products show some seasonality here. This one as well, and this one has a very spiky character. And here you see a final report and how the visualizations was used. So the report could be about something else, and the visualization was kind of neutral in that sense. So here you have two completely different types of visualization. This one is very informative, and that one is all about form. And that's a well-known trade-off, well, maybe the form-function trade-off, but in visualization you also have this trade-off very much. So if aesthetics is something that you should try to achieve, because that creates a long-term engagement with the user, the risk is, of course, that if it becomes too aesthetic, let's put it that way, it becomes kind of an artistic project where you don't get any information out of it. So the trick is to find a balance between creating something that's really beautiful and nice and aesthetically pleasing and engaging, and at the same time also have this informative value, a part of your visualization as well. So for the remaining part of my talk, I will show you some of the concepts that I think are related to this balance and how you can apply that. And the first one is interactivity. And this first project is another personal project. I really like what I do, so I do a lot of personal projects as well. And this is also about the elections, and in 2012 in the Netherlands. And whenever there are elections, people ask questions: which party has won, which party has lost, what are possible coalitions? We have multiple political parties in the Netherlands, and etc. So these are all valid questions, nothing wrong with it. But I had a slightly different question: which cities vote in a similar way? And I was not interested in just the biggest political party in each city. You can see maps in the news for that all the time, and regions colored by the color of the political parties and things like that. But I was interested in the complete voting profile. So a lot of votes on this party, not so much on this one, a little bit more on that, and which other cities have the same voting profile. So conceptually, it's something like this. So you have these two imaginary voting results. You just overlay them, and you sum up the differences. And you can imagine that if the sum is 0, they voted exactly the same. If the number is bigger, then there's a bigger difference. So conceptually, it's something like this. This is the visualization that I created. It's a map of the Netherlands, although I actually didn't draw a map. The Netherlands is really densely populated, so you can see the shape of the Netherlands. And what you can do, you can click on every city in the Netherlands. And once you do that, the circles become bigger and more orange. And other cities do that as well, if the voting profile is more similar. There's also a second layout, which is a radial layout. And in this layout, the selected city is in the center, and other cities, if they have more similar voting result, they are also more to the center. On the top left, you see the actual voting results for the selected city. And if you hover over other cities, you can see small lines, so you can compare the actual voting results. I also included another data set because I thought maybe there's some kind of correlation between big cities and small cities, so that's the population size of each city. So the question, of course, is, are there some insights to be found in this data set? And it turns out there are. So first of all, there are several regional clusters to be found. This is around the city of Eindhoven. Eindhoven is considered to be one of the largest cities in the Netherlands. And Eindhoven itself is not part of this cluster. So it's just the cities around Eindhoven that vote in a similar way, and at the same time different from the rest of the Netherlands. You can find multiple regional clusters in this map, and one interesting follow-up could be, will these kind of clusters remain the same regardless of what people vote? Another insight is we have a Bible Belt in the Netherlands, and if you select one city of the Bible Belt, then, well, you see other cities of the Bible Belt. Here I've selected a city that's associated with rich people, and there are a few more of those cities, and they also show up, and you can see that there's one political party that is also associated with this rich people. The correlation is not that strong, but you can see that bigger circles are more on the inside than on the outside, so big cities also kind of vote in a similar way. And as in many data sets, there are also outliers. This is Urk, and there's really no city that votes like Urk. There are even political parties they don't vote on. So this was a very successful visualization. This was very successful, I think, at least, because I literally received emails from people that they spend 30 minutes during work time playing around with this visualization. So for me, that's a good sign. And one of the reasons I think this was a successful visualization is because it has concepts a little bit similar to social media, where you can keep scrolling. Sometimes you find something interesting, and sometimes you don't. And that's also what you can do with this visualization. So you can click on all of the cities, and sometimes you see a pattern, and sometimes you don't. And at the same time, I'm also not explicitly communicating what the insights are. So the Bible Belt and the rich cities, those were little experiments I tried myself. And so users can also do their own little experiments. And I think, I don't know if there's a kind of a recipe or rules for how to achieve this, but if you are able to find this balance between people exploring and finding something that could be a very engaging visualization. And so in the sense of constructing knowledge, so this way, if you spend half an hour on this, I'm quite sure you learn a little bit about how the Netherlands voted. Another project related to interactivity is this project, and this could be a sustainable development goal project. It's a project I did for Figshare, and Figshare is a UK-based organization, and they have built a platform where scientists can share their data for other people to reuse. And they asked me to create a visualization to see what would happen if a data visualization designer reuses this data. So I used this data from NOAA, from the United States. They do a lot of well, specifically for this project, they do have a monitoring project for islands in the Pacific. And so what's happening there is that they go to these islands every now and then, or every year or every several years, and then they dive and they make measurements about the state of the reef and also about the fish population. And so in that sense, you get a very large data set with all kinds of measurements, so time-based, space-based, and other types of attributes. Time and space in visualization is always a challenge. So here are a few examples from research where they try to tackle this problem. Here you see a map, and it's kind of a heat map on the border of a map, I guess. And in this particular situation, it works, but you can imagine that if the border would wrap around, then yeah, the visualization would occlude parts of the visualization would be occluded. Here's another one. Here you see some measurement values around a region, but the lines are overlapping, and it could also be a little bit tricky to read. Here they created some kind of coils on a map, and well, you cannot see the back, and the height is a little bit hard to understand. So there are always challenges with time and space visualizations. I had my own challenge. Let's say that this is an island. The thing is that these researchers, they didn't dive at the exact same location when they went back. So if every color represents a different year, well, you have diving locations at different locations over time. So how are you going to solve that? Maybe aggregate over time in space or something like that? I don't know. So one idea I had was maybe if you have this island, maybe I can grow the shape of the island based on the data values, so or shrink it. But yeah, then if you have a bay like that, then you get a lot of overlapping lines again, so that also doesn't really work. And it also turned out that there were situations that were not even islands. It was just a reef, so you don't even have a shape of an island. So this is the visualization I created. You see the shape of the island itself, but it's actually just the diving locations that you see there. Then around the island you see a set of circles, and that's every circle is a year. The most inner circle is the earliest year, and the outer circle is the the most recent year. And so what I've done is I connected each diving location with a measurement value on a certain year. So, and the color represents an increase compared to the initial year, or a decrease. So blue is an increase, and red is a decrease. And yeah, so there on the top you can select different measurement values, and so based on the color you can see that some of the values improved and some of the values did not improve. At the bottom you can select different islands. And one of the things that I also included is, it's an interactive visualizations, you can move things around, because you can have situations where you have overlapping lines or measurement values are overlapping. So what you can do, you can move around your point of view so that you can position that at a specific location so that you can see values that are otherwise overlapping. So in this case, interactivity is really helping exploring this data at specific situations that would otherwise not be possible. This visualization is also a nice bridge to the next concept, because as you can see at this design, it's about diving and things underwater. The colors that I've used suggest as if you are underwater, and the lines, I was inspired by sun rays as you would see them underwater. And so I used this concept of being underwater to influence my design decisions. And so the next concept is using metaphors in your design. And this is a project I did for Nature magazine. And I don't give the title away because I have a question for you. Because it's a project about the research about the total number of trees in the world. And so obviously my question for you is, how many trees do you think there are in the world? Any guesses? How much? Yeah, you have to calculate that for me. 50 trillion, that's a little bit too much. But 70 million, no. Well, 100 times? It's 3.04 trillion trees. Exactly right, yeah. Yeah, so that's right. That's so 3.04 trillion trees. And so for this project, I created an animation, and let me show you the animation because it explains for itself.
How many trees are there in a forest? What about a country? How about in the whole world? The answer, we now know, is that our planet is home to 3.04 trillion trees. That's actually almost 8 times more than we thought, as previous estimates were only based on satellite pictures. But now, we have data not just on how much land is covered in forest, but how dense those forests are as well. Measurements were collected by thousands of people out counting trees in forests all over the world. The average density of trees at each location is represented by the height of the green lines. Some of the densest areas are these subarctic forests, where you can find a tree every square metre. But almost half of all our trees are found growing in the vast tropical and subtropical forests. All this data is going to help our understanding of where endangered species might be able to live, how water is cycled in an ecosystem, or how much carbon dioxide is being absorbed from the atmosphere. It also helps us work out what we ought to be doing to preserve and replenish our planet's forests. Because even accounting for new growth, we're currently losing about 10 million trees a year. At the moment, there are about 400 trees for every person on Earth, but they're disappearing at a rate of 1.4 trees per person every single year. If we keep going at this rate, a walk in the woods will soon become a lot trickier. Thousands of years ago, before human civilization took hold, the Earth had almost twice as many trees as it does now. Most of Europe, for example, was one big forest. Groups all over the world are working on planting trees and restoring natural habitats. This new data will make their targets more accurate. And it will certainly change our fundamental understanding of our planet that we now know we share with 3.04 trillion trees.
So that was the animation I created. And since it is about trees, what I was trying to achieve was to create a texture-like appearance, just like the roof of a forest or a jungle or something like that. But it was kind of tricky to do because, well, here are a few samples of some of the intermediate sketches I created. I really didn't manage to create this appearance for quite some time, actually. I tried a lot of things, but nothing seemed to work. So as you can see, over there, it's just one big green area. But eventually, I was able to solve it by creating a gradient for every line. Every line has the same gradient, but because the height of the line is the density, and they could have different heights, but the gradient range is still the same. It means that if a longer line is next to a shorter line, the colors are slightly different next to each other. And that creates this kind of forest appearance. And well, it ended up on the cover of the magazine, and as well as in the magazine with a 2-page spread with all kinds of cutouts of the visualization. So whenever you're visualizing something about the physical world, you can use elements or properties to drive your design decisions. And I'm not the only one who does that. So this, for example, is the wind map by Martin Wartenberg and Fernando Viegas. It's online, and it's an interactive visualization, almost a near real-time visualization of wind data in the United States. And I haven't seen the weather here in India on the news, but in the Netherlands you often see arrows flowing around on the weather map. That's usually not how I experience the wind myself. This is much closer to what you think of when you think of wind. Now, the final concept I would like to dive a little bit deeper into is storytelling. And first project is a project I did for the European Space Agency, and it's about this satellite. And this satellite took measurements of stars, about 100,000 stars, and at that time it was more accurate than anything that had been done before. Obviously, this data was available in large data sets, but also in a big pile of books with tables and maps like this. The European Space Agency had a follow-up project called Gaia, where they measured 1.5 billion stars and even more accurate. And as a kind of a stepping stone to that project, they asked me to create a visualization for science-interested people to show what is inside a star catalog, what kind of data and what kind of measurements are in there. So this is the visualization I created. This is the home screen. And when you click on the Start button, you come on a screen like this, and every screen is organized like this. So on the right, you see a title and a short description of what you're looking at. At the top, you see some suggestion how to interact with this visualization. At the bottom, you see the steps of the visualization. Here at the left, you have a few buttons that help you orient yourself, so you can turn on the labels and the constellations of stars. And well, obviously, the choice of constellations was a very human decision from Earth, because if you zoom out, it doesn't make sense anymore. Finally, this is a very focused view only on one single topic. So this is about the apparent magnitude. And the apparent magnitude is the brightness of stars as if you would see it from a certain point in space. So here with the slider, you can change the apparent magnitude. And yeah, there you can read it. So the next step is the absolute brightness. And that's the brightness of stars as if they would be at the same distance from the observer. And so that's what I've done here. I'm not showing the actual position of the star, but I'm showing the concept. So this obviously is not reality, it's the concept. The next step is the Hertzsprung-Russell diagram. It's a diagram that tells scientists something about the life cycle of stars. So here at the bottom you see temperature, there you see brightness of stars, and here the color of stars is introduced based on the temperature of stars. And so the position of a star tells you something about the age of a star. This is about stellar motion. If you look up in the sky, you think stars are stationary, but they're not. They actually move around. So this is a simulation of stars moving through the sky. This is not three-dimensional. This is two-dimensional projection, a stereographic projection, but they change in size based on brightness. So they move in two-dimensional space, but they change in size based on the brightness. So it still has some three-dimensional appearance. And finally, you have a view where you can do everything at once. So you can change the brightness that you're looking at, you can turn on or turn off the color, you can start the motion simulation, and you can look at it in 3 dimensions or the two-dimensional projection. This one is also available online, and if you look at it, you can also find stars that move in clusters, so they move together in the same direction with the same speed. And that's one of the things scientists are interested in. So the reason why I'm showing you this project is because the way this visualization is structured, because it is a way of data-driven storytelling, and it's sometimes called the martini glass structure. Martini glass is very narrow at the bottom and then it opens up. And it's a way to structure your story if it's a little bit more complex. So first you introduce topics step by step, very narrow focus, limited interactivity. And then at the end, just like the martini glass opens up, you can show all the controls and users can play around with it, because then you can assume now he knows what he's doing, so you can give him all the options. Otherwise, it could be a very confusing situation for a user. So this is one way to structure your data-driven story. Another way is a project I did for UNICEF. It's about child mortality, and here you can see that in 25 years, child mortality has dropped about 50%, which is really good, of course. And also the newborn death has also dropped. But the drop for newborns wasn't as big as for child deaths in general, so it becomes a bigger problem of newborn deaths. And so there are differences within regions, or between regions, just so you can select certain regions, and you can hover over it to see which regions they are. And then finally, there are also differences within regions. Now, as you can see, the idea of this project was to communicate this information to a very broad audience. So you can assume that, it should also be understandable for people who have no data literacy at all. So therefore, we used very simple charts, so just line charts and animations. But the way this visualization is structured is sometimes called an interactive slideshow. So it's just like my presentation right now. I go through from one slide to the next one, but you also offer some interactivity. The story itself is told using the text over there, and then it's illustrated with very simple diagram. So this is another way to structure a data-driven story. And finally, what I would like to dive into is the message itself you're telling with a story. It's a story I did for the World Food Program. It's about the efforts they did in the fight against the Ebola crisis several years ago. Officially, I was not allowed to talk about this project. That was in my contract. But yeah, then people from the World Food Program started tweeting that I did it. So yeah, now it was in the open anyway. So it was okay for me to mention it in conferences. So it's okay. The idea was that they had a conference in Turkey, and they wanted to show to other people what they did, all their efforts, and because they put a lot of effort in fighting in the Ebola crisis. So here you see some of the people at the conference with their booth and the big screen with the visualization. So here's the visualization, and it looks like it's kind of structured in a similar way to the European Space Agency with the several steps, but there's not really a conclusion here. So what they wanted to do is to show the different operations they had. So they had logistics operations, engineering, and you can select any of those on the right. And then you see different maps which you can filter, and you can also filter on dates, and etc. And what I've tried to do is to have, because all of those are maps, and what I try to do is have those three countries, or the capitals of the three main countries, visible all the time, and then you see the transitions between the different views. And so here you see some of the facilities, the communication facilities they constructed, and engineering, because they build helicopter landing sites, storage units, hospitals, etc. So, yeah, they did a lot of things. Now, what I wanted to illustrate is that, so this was for the air coordination cell, and they did a lot of transports from some of these countries to the affected countries. And this is what I initially came up with, and I thought it was a very good idea, because you can, well, there's really a distinction between the countries where the flights were coming from and the countries that were affected, and you can also distinguish the individual lines, and so it makes use of the available space nicely. So I thought it was a good idea. They thought it was not a good idea, because they had a different thing they wanted to communicate. What was more important for them was to communicate that they traveled long distances in order to get all the stuff there. So they preferred something like this, where all these countries are there, but all the way, they came all the way from Shanghai, and so they wanted to show long lines. That was really more important for the message than to clearly see what how many flights are, because right here you can see there are a lot of overlapping lines, so it's a little bit more difficult to distinguish them, but that was not the important message for them. So with visualization, you can really tailor your message, or tailor your design to the message you want to communicate. Another thing is this. Sometimes you run into situations where, well, I run into situations where they ask me, we do a lot of things, so can you show that? And usually when you start aggregating data, you lose all the details, and so it becomes one single dot or something. And so sometimes it makes sense to show all the data at once, because that gives you the impression it is really a lot. And that's what I try to do here with all the flights that left from Germany. But at the same time, when you do that, you also have to consider design itself. So here you see already the patterns, and it's really hard to actually see how many lines there actually are, and comparing that to the other ones, and there are a lot of overlapping lines. So even though this was showing all the flights and showing that it was a lot, in this case it was actually better to aggregate it and show the individual lines, and that was much easier to see. One other thing that was quite interesting, it's not really about the message itself, but you have to imagine that when World Food Programme was working there, data was not their primary concern, of course. And apparently I think they don't really have some technical facilities in place to do this in a very structured way, always, probably because they work in very different situations. But the result was that data was a side effect for them. So I received data in PDFs, in Excel sheets, in Word documents, even written out in an email that I should use. There were different abbreviations, namings, etc. So there was a lot of data cleaning that was required in order for this project to get started in the first place. And here you see even this and this is the same helicopter landing site, but there were multiple people authoring this data, so the same site could be positioned in different locations. So there was data cleaning involved in many places. So finally, I would like to thank you, and I would like to close off with the thought that whenever you see a visualization, think about how a visualization uses aesthetics to facilitate the fact that a user should construct knowledge himself so that he understands what the data is about. Thank you very much.